Hello there and welcome to a video on the answers to logo, a practice internal where we're just dealing with logos. On this particular one here, we're going to start off with the achieved questions, and we start off with this graph over here to the left. Now the very first thing that we do when we're looking at this graph here, it is obviously a hyperbola. It's in two different quadrants. It seems to have asymptotes that have not moved anywhere. You wouldn't expect any to move anywhere, so they're obviously just still sitting here on the axes. So you've got one asymptote coming straight down there and one asymptote coming along here. Because they haven't actually moved anywhere, these particular asymptotes haven't moved anywhere, therefore you know that it is of the form y equals something over x. Now all you have to do is just get 1 point. Now if you go across 1 and up 25, it tells you there, we know that this value here, a, we know that x, y equals a, so we just have to multiply those two numbers. 1 times 25, 1 times 25 equals my a value, so it's just 25, so I get y equals 25 over x. Right, that was the very first one. Let's have a look at the second one here. The second one, again, it looks like it has an asymptote coming along the x-axis. It is, by the way it's curving up, it is going to be a power graph. Now with these power graphs, the first thing that you really want to do is you want to see where it is one off the axis. Now this one here is one off the axis right there. Therefore all you want to do is you want to go across 1 from where it's one off the axis. If you go across 1, and how far up do you go will give you what your base is. And this particular one, if you go from there, if you go up, across 1, up 1, you actually get 3. That's one of the points that they gave you. So that's where the 3 came from. Right. The next thing that we want to do is we want to work out what this last one is. This last one is obviously a parabola. It is a nice U-shaped graph. Now we normally expect that to be sitting on the origin. It has moved to the right 6 and it has moved up 10. So that is where that 6 comes from there, and that is where that 10 comes from. Right, on each of these, the domains, the domain for this particular one here is just, x includes all real numbers, so it's everything. However, at your vertical asymptote you can have x cannot equal 0. Each of these other domains are straightforward. You just got from -2 to 2. That's strictly less than and strictly less than signs there because you've got open circles. And again, this one here is from 3 all the way up to 10, which is your 3 and 10. And again, there's no closed circles, so there is no less than or equal to signs. Right, if we head down, went a little bit too far, if we head down to the merit, first thing we've got over here is we've got a cubic, and the first thing that you look for is you look for its intercepts. You've got one at 5, you've got one at 3, and you've got one at 1, which is where that 5, 3 and 1. Because they are negative, you know that you have to have a plus in each of those. Next thing you look for, of course, if it's going to be a merit question, you will have a number that's in the front there. So what you do is you choose a point. This one here we've got at the point 0, 30. So what we do is we just substitute in the value 0. So we know that 30 equals some value that we've got on the front, a, and then we've got 0 plus 5, which is just 5, 0 plus 3, which is just 3, 0 plus 1, which is just 1. So we have 30 equals 5 times 3 times 1, so we get 30 equals 15a. So we know straight away that a equals 2. That's where that 2 there comes from. Right, next thing that we want to do is, let's rub that one out. Next thing that we want to do is we want to have a look at this parabola. Now again, do we have its intercepts? We do. We have one at 3 and we have one at 7, which is why you've got a 3 and a 7. It's to the right of the y-axis, so therefore they must both be negative. Then we look for a point, and this one here we've actually got a point of 5, 8. Now if we actually go across to here 5, 8, all we have to do is we just have to substitute this in. So we've got y equals, we know it's going to be a negative because it's upside down, so y equals negative a into 5 minus 3 into 5 minus 7, and all of this is supposed to equal 8. So 5 minus 3 is 2, so we get minus a into 2. 5 minus 7 is actually negative 2. It's got to equal 8. So we're left with 4a equals 8, so a must equal 2. So that's where that 2 there comes from. Right, we've only got one more function left here for merit. Get my eraser in. We've only got one more function here left here for merit, so let's go in and have a look at that. That is an absolute value function. Right, the first thing we look for is the magic point there, which is where its vertex is. So it's going to cross 8 and up 30, so that it's going to cross to the right, so it's a minus 8 and it's a plus 30. The next thing that we look for is how far do you go across and how far do you go down. A standard absolute value will be the same that you go across to the same that you go down. Now this one here, it's at the 30 there, and then that one there goes to the 20. It has gone across 2 and it has actually gone down 10. Remember, we expected across 2 down 2, so this one has actually gone across 10 down, across 2 down 10, so that means it is 5. It is 5 times bigger than what we'd expect. Because we expected it to be 2, it has actually gone down 10. So remember, this is always the expected, and that's the actual. We expect if you go across 2 that you go down 2, so we expect it to be 2. It's actually gone down 10, so therefore the number in the front must be 5. It's negative because it is upside down. Okay, that'll be enough for this particular video. Thank you.